That 1/5 right there, it deals with the 5. Look at the 7. It's 1/7 4c over pi. So you start to see patterns emerge, okay? Now you could just write down 9, 11, like you could just write them all down, and you could have a very accurate Fourier expansion. And now let's plug in. So this is the final step. The final enchilada. Okay, so I'm going to get rid of this because this was just demonstration. We need that little space there. Okay, here we go. F of x is approximately equal to, it's approximate because we're not doing an infinite number of terms, we're just doing a few. Now we got all the b's. Okay. You see it's the sum? All these terms are gone, so we're just dealing with these b terms. So we're just summing them up. b1, 4c over pi. So b1, and let's just write it down. It's going to be b1 times the sine of n pi x over L. So n is 1, pi is pi, and then L is pi. So the pi's are always canceled. So this is going to be b1 times the sine of x. And this is the sine of 1x, isn't it? But I'm making note of that. You'll see why it matters. So then this is plus b2. Well, all the even b's went away, times the sine of 3x. b3 times the sine of 3x. Plus b5 times the sine of 5x. Plus b7 times the sine of, did I make it in? Just barely, good. Okay, so now plugging in. The first one, 4c over pi. YouTube recently gave us permission to go over 15 minutes, so hopefully we're not there, but if so, we've got it. Plus, you probably need a bucket of popcorn for this damn problem, huh? Okay, so this is 4c over 3 pi. See, I don't even see. I know the pattern now, right? 4c over 3 pi sine of 3x plus 5c over 4c over 5 pi. What's really frustrating is when you make a mistake at the very end and you have to redo this damn thing. But that ain't gonna happen. We're on the ball here. This time, 4c over 7 pi times the sine. Did I make it in? Barely, I can barely see that. So let me write that underneath. I know, I just write more compact. Plus 4c over 5 pi times the sine of 5x plus that's a plus 4c over 7 pi times the sine of, man, I don't know if I made it in or not. Yeah, you can see it. I think you can see it. This last term, I'm going to call it out to you audibly. 4c over 7 pi times the sine of 7x. 4c over 7 pi times the sine of 7x. There's a 7x in here, is what's supposed to be in there. Okay, done. Is that not a monster? Okay, so practice. Try this one out. You need to try an even one out. You need to try one that works out, odd and even. It's useful for modeling. It's one of this to me. This and matrices to me is the most brilliant mathematical thing that's ever come along. This guy was just, this is incredible. Also, Joseph Fourier, that is. Take a calculator and graph it. So let's C equal to 1, okay? Let's C equal to 1 and graph this thing and see what you come out with. You will be, it's cool. It's really, really cool. So it's going to do this number. It's really cool to see it when it happens. It'll come up and it'll come over like this, and then it'll come down and it'll come over like this, and then it'll come up and it'll come over like this, and it'll come down and it'll come over like this. It's really cool. And then let your X scale be pi over 2, so you know what your you know that it's hitting where it's supposed to hit. Just so you can watch it just in awe. I remember the first time I got one, I was just like, that is cool. Okay, I'm gonna step aside and give you a clear screenshot.